Alright, so now we're going to look at binary operations. We're finally at binary operations, right? And binary operation, well, what's a binary operation? A binary operation, how they define it, they love to call a binary operation star. And so if we have a binary operation star and a non-empty set, right, we say A star B equals C, where both A, B, and C are all elements of some set, right? So that's pretty much what binary operation is, but in my definition of a binary operation is just an operation that constitutes of a mixture of all of the basic operations of mathematics. So for example, let's say we know that A plus B is the addition of two numbers, right? That's addition operation, we have subtraction operation, division and multiplication. Now I can have an operation defined as A star B is equal to 2A plus 2B divided by 2Z. Now that's 2 times some number times 2 plus 2 times some number divided 2 but 2 times some number. So that's a lot of operation taking place right there. Now all of those operations taking place come together to form one operation. This operation is known as a binary operator. Alright, that's all is binary operation. So here on the screen I've displayed what a binary operation definition is, but ignore all of this and listen to what I say. A binary operation is just an operator that involves a mixture of all the basic 4 operations. That's a binary operator. Easy, soft. Alright, now let's look at the properties of binary operation. So remember, we define the binary operator as star. And so what we can therefore say is, if we have, for example, a binary operator is defined as star, the first property is commutativity. We said that a binary operation is commutative if A star B is equal to B star A. That's when a binary operation is going to be commutative, if A star B is equal to B star A. So let's check it out. It says star is commutative if and only if. So that's some reasoning and logics there. That's a biconditional statement, but we're not looking at reasoning and logics. Let's just get to binary operation. But this is the beauty of mathematics. So just linking all of our knowledge, right? So here's the biconditional statement. Star is commutative if and only if A star B is equal to B star A. So for example, it says show that the operation A star B, which is 2A plus B plus A plus B, is commutative. So to show the first part right there, alright, let's do the solutions over this side. Right? So to show it, I'm going to write in red now. So A star B, it defines A star B as 2A, 2 times AB plus A plus B. That's A star B. Now let's say I wanted B star A. B star A would mean I interchange B for A and A for B. So B star A is 2 times B times A. I interchange B for A plus B plus A. But according to real numbers, when I multiply two real numbers, they are commutative. And so this can be worked out to be 2 times BA is the same as AB plus the sum of two real numbers is commutative, and so I can rewrite this as A plus B. But then 2AB plus A plus B is A star B. And so since A star B A star B is equal to B star A, then we say that the operation star is commutative. Alright, so that's commutativity. Now the next one is to show that star is associative, and star is going to be associative if we have three numbers A, B, C. So we have A star, B star, C. It's associative if the order does not matter. So we can work out B star C first, then say A star the result of that, or we can go A star B and the result of that star C. Alright? And so this question says show that operation A star B, which is equal to 3AB, is associative. So let's show that that is associative. So to show that it is associative, we're going to start with A star B star C. So we're going to start with that now. A star B star C. Now A star B star C is going to work out to be A star. What's going to be B star C? B star C is going to be, now A star B is 3AB, and so B star C is 3BC. That's B star C. So since B star C is 3BC, so now we need what is A star 3BC. The result is 3 times the first number, so it's 3 times the first number A times 3BC. And so what we're getting is 3A times 3BC, which is 3A times 3BC is 9. This is 9ABC. So we're getting 9ABC. So that is A star B star C, which is 9ABC. So now that the result is 9ABC, that is A star B star C. Alright? So the next thing that we're going to want to show is to show that A star B star C is equal to A star B star C. So we have A star B star C. But what is A star B? A star B right here is 3AB. So it works out to be 3AB. And so we want to find what is 3AB star C. Now 3AB star C is 3 times the first number, which is 3ABC, times the second number, and the second number is C. Alright, and so 3 times 3ABC works out to be 9ABC. And so what we can conclude then is A star B star C is equal to 9ABC, and A star B star C is 9ABC. And so we've clearly shown that A star B star C is equal to A star B star C. So the order does not matter, and so star is associative. Now the next thing to look at is to determine if a binary operator star is distributive over another operation. In this case, it's delta. Now a binary operator star is distributive over a second binary operator delta if A star B delta C works out to be A star B delta A star C. That's the only time a binary operator is distributive over another. So let's check out this example. So we need to show that A star B delta C is equal to A star B delta A star C. So we need to show that A star B delta C, A star B delta C, it should work out to be A star B delta A star C. This is when it's distributive. So we have A star B delta A star C. And so let's show that this is distributive. So now this is going to be distributive if star is distributive over delta, if A star B delta C is equal to A star B delta A star C. Now also delta can be distributive over star if we had A delta B star C equal to A delta B star A delta C. So they could also ask you for that to show that delta is distributive over star. Well, let's check if this is true. So on the left hand side we would get A star B delta C. Now what is B delta C? From the question given, they tell us A delta B is AB, and so B delta C is BC. So that would be on the left hand side. Then we need A star BC. A star BC is equal to A raised to the log B. So A star B is A raised to the log B, and so this works out to be A raised to the log of BC. This means raised to the power, so this is A raised to the power of log BC. Now let's see what over here works out to be. It says show that star is distributive over delta. So A star B is working out to be A star B, this part right here is A raised to the log B, A raised to the log B, delta A star C. A star C is A raised to the log C. So what we need to know is work out A to the log B delta A to the log C. Now A to the log B delta A to the log C. So we have some number P and Q. P delta Q is P times Q. So this works out to be P times Q. But then now when you're multiplying two logs, now watch this now. You're multiplying two logs, but not just logs. Whenever you're multiplying two numbers where the bases are the same, you add the powers. This is laws of indices. This is from CSEC. So this is CSEC, right? So we add the powers. So we have log B plus log C. But what is the rule of logarithm? The rule of logarithm tells us that what we can then do is rewrite this as A to the log B plus log C is the log of B times C. Now look at it. The left hand side is our right hand side, and so clearly we can say that star is distributive over delta. So we've shown the first one. So star is indeed distributive over delta. Now let's show that star Alright. So let's show the second part that star is non-distributive. Let's show that delta is non-distributive over star. To show that delta is non-distributive over star is we're gonna have to show that when we work it out, the results, the left hand side and the right hand side are not going to be equal. So I've accidentally erased the question, so let me just write it back. So we have A star B that's equal to A raised to the log B, and we had that A delta, alright, so I'm forgetting delta. How did I get delta again? Alright, so I'm not going to use delta, I'm going to use dollar sign. I forgot how I got the delta sign in there. So it's A dollar sign B, and A dollar sign B is equal to A times B. And so now show that, the next part was to say, show that dollar sign is non-distributive over star. So that's what we're going to show. To show that dollar sign is non-distributive over star. To show that dollar sign is non-distributive over star, we're going to have to start by writing down the statement. Alright, A dollar sign let's say A dollar sign B star C, we're going to have to show that this is not equal to A dollar sign B, A dollar sign B star A dollar sign C, A dollar sign C. So we're going to have to show that A dollar sign B is not equal to A dollar sign C. That's what we're going to have to show, that it's non-distributive. So let's do that. To start with the left hand side, B star C would be, this part would work out to then be A dollar sign. Now B star C is going to work out to be B raised to the log C. This part is B raised to the log of C. Now B raised to the log of C, that's what we have. Now A dollar sign B raised to the log of C is just A times B. This works out to just be A times B to the log of C. That's what we have. So now let's work out to the right hand side. Now A dollar sign B is AB star A dollar sign C is AC. And so now what we have is AB star AC. Now AB star AC is the first number AB raised to the power of the second number AC. Now AB raised to the log of AC, remember AB, it's all of this, AB raised to the power of the log of AC. Clearly this cannot be equal to this. Clearly AB log C can't equal to AB log AC, right? And so that concludes it. So dollar sign is non-distributive over star, or star was distributed over dollar sign. So that's what we do for the distribution. That's all there is to binary operation. Commutativity, associativity, and distributivity. Of course, later on in life, if you're doing mathematics at the university level, you're going to learn about symmetry and all of these stuff, right? But we don't need to look at that, right? You don't need to look at those stuff. This is all you need to know for K mathematics, right? Easy. Let's go. The next thing that we want to look at is the identity of a binary operation, right? There's a test that you carry out for the identity of a binary operation. So it is just like when we were looking at the real number system. So whenever you have some number A and it undergoes a binary operation, the result must also give you back A, and then that element that made us get back A is known as the identity of the binary operation. So in all of that words I'm explained, mathematically it is just A undergoes some binary operation star, then that element E gives us back the result A, and so E is the identity. E is the identity. And that's how you find the identity of a binary operation. So for example, it says, it gives us an example, A star B is equal to A plus B minus 8. And so all we're going to do to find the identity is solve this equation, A star E equal to A. So replace B with E and set it equal to A. But then A star E would be A plus E minus 8. So we get A plus E minus 8. Then the A's cancel. And so the identity of star is 8. The identity of star is 8. That gives us the identity. Now the inverse. The inverse of a binary operation, often written as A to the minus 1. The inverse is whenever we have some number A and it undergo a binary operation star, the result is the identity. And so what we basically say is that if we have some element A and it undergo the binary operation star for some element A to the minus 1, and we get back the result, which is the identity E, then we say that A inverse is the inverse of the element A. This is the inverse of the element A since the result was the identity. So here, so we solve A star A inverse equal E, and then we'll make A inverse the subject, and then we get the inverse. So for example, we already found that the identity was 8, and so solving A star A to the minus 1 equal E. Now A star A to the minus 1, replace B with A to the minus 1, and so we get A plus A to the minus 1 minus 8 equal 8, and so we bring over the minus 8 to get 16, then we bring over the A to get minus 8, and so A to the minus 1 is 16 minus A, and so the inverse of A is 16 minus A. And that's all there is to finding the inverse of a binary operation. Easy, soft. All right. And that's pretty much it. So what we're going to be doing now is we're going to look at our worksheet, and we're going to solve 2 questions on binary operation. So that's going to be 2 practice questions, and that's it.